The first type of function that we'll be working with in this class is the power function. A power function y equals f of x can be represented by an equation of the form y equals k x raised to the p power, where k and p are real numbers. That's the only requirement for a power function. So we're going to be looking at these examples here to determine which one is and isn't, and then give a little rationale as to our answer here. Our first function, s of x equals negative 7 x to the third. This is a power function, and the reason for that is if we look at the k value, constant in front, and the power, number 3, those are both real numbers. Going back a little bit, something that's not real would be like the square root of negative 1, for example, or the square root of negative 25. You can't think of a real number times itself that'll get you back to those numbers. In this case, pretty much any other number that you can think of is a real number. The next example, m of x equals 5x to the negative 4 power. Again, we focus on the constant, or the coefficient rather, in front, and the power, negative 4. So 5 is a real number, negative 4 is a real number, it's an integer, that's fine, it's a real number. So in this case, again, we're looking at that is a power function. The next one looks a little suspicious, but we're going to need to go back to what we learned in 130a. Excuse me, the next function is j of x equals negative 8 the square root of x. So that's negative 8 times the square root of x. What you have to remember, though, is that square root of x, the root is 2, the power is 1, and we can rewrite the square root of x as x raised to the 1/2 power. So if I rewrite this as negative 8 x to the 1/2 power, both negative 8 and the power 1/2 are real numbers. So in this case, that is a power function. About now, you're thinking, well, what the heck is not a power function? Well, if you look at k of x, notice how this one's different. This is k of x equals 3x squared minus x plus 8. There's a lot of extra terms going on here that it's not just one term, and in fact, our definition of a power function is it's just one term, kx to the p power. In this case, this is not a power function because you have too many terms. If it had just been 3x squared, we'd have been okay with that. That would have been a power function. But because you subtracted x and added 8, you've adjusted that, and it's no longer a power function. So the general power function has an equation of the form y equals kx to the p. Now we want to examine how the behavior of the power functions depends on two parameters, the coefficient k and the power p. So we're going to see what happens to our pictures or our graphs when we start adjusting those numbers, the k and the p. So first we're going to look at our even power functions. F of x equals x squared, g of x equals x to the 4th, h of x equals x to the 6th. And we're going to complete the following table and then graph these functions. So they're giving us the input values for x, negative 2, negative 1, 0, 1, and 2. And we're going to plug those into the functions f of x, g of x, and h of x to get the corresponding output values. So for example, f of negative 2 would be to take the number negative 2 and square it. So negative 2 times negative 2, positive 4. And we get its output. Same with negative 2 plugging in for x and raising it to the 4th power in the g function. Negative 2 raised to the 4th power is positive 16 because you're taking the number negative 2 and multiplying it times itself 4 times. And similarly for h of x equals x to the 6th, we're plugging the number negative 2 in for x raising it to the 6th power. Anytime you take a negative number and raise it to an even power, your answer is going to be positive. So this comes out 32. So 2, 4, 8, 16, 32. All right. And then the negatives all turn to a positive at the end. Do the same for -1. Input into f of x equals x squared, and our answer is going to be +1. If I take -1 and put it into the g of x function, -1, the quantity raised to the 4th power, also +1, and -1 raised to the 6th power. So the number -1 times -1, 6 times is going to be +1. Substituting in the number 0 into our functions, into x squared, 0 squared is going to be 0. 0 to the 4th power is also 0, and 0 to the 6th power is 0. +1 squared, +1. If I plug in the +1 in for the g function, 1 to the 4th is 1, 1 to the 6th is 1. And then plugging in the 2, 2 squared is 4, 2 to the 4th is 16, 2 to the 6th, 32. Now I could graph these on this graph here. This graph's a little sparse. There's no units on our axes here. I could also go to my graphing calculator. So at this point, if you go into your graphing calculator, and I think it helps to see all of these at one time. Let me make my screen a little bigger here if I can. All right, and type in y equals x squared. So we go and hit the x raised to the 2 power and graph it. And what we see is like a horseshoe shape pointing upward, or a parabola pointing upward. If I type in x to the 4th, all right, so I'm going to go x raised to the 4th on line number 2 of my equation editor, graph that. And the difference between the two is that the x to the 4th was, for lack of a better word, a little skinnier, right? It's brought in closer to the y-axis. So x squared is kind of hanging out here. X to the 4th comes in a little skinnier. So your guess would be for x to the 6th, it's probably going to be even a little bit skinnier than x to the 4th, or it's going to be what they call vertically stretched. All right, so let's take a look at that graph. Goes in just a little bit tighter to the y-axis, or it's vertically stretched a little bit more. All right, so we're just going to kind of, just to remind myself what these look like, I'm going to put this first one in, and notice it did touch at 0, 0 here. Mine's really bad here, but let's call that y equals x squared, or f of x equals x squared, just to kind of remind myself. And then x to the 4th came in a little bit tighter to the y-axis, still hitting at 0, 0 down here, because we all had the point 0, 0. And it goes back up on the other side. So that's going to be g of x equals x to the 4th. And then x to the 6th was just a little bit tighter, a little bit closer to the y-axis. Not much though. Came in looking something like this. And again, hitting at 0, 0 and then going right straight back up. So again, a bit of that horseshoe shape going on. So for that one, I'm going to call that one h of x equals x to the 6th. And those are our 3 power functions that have an even power and a coefficient of +1.